Right, EIGRP in enterprises. What is enterprises? A big organization. So in a big organization, we got many networks. When we got many networks, many advertisements, many updates, bigger updates. Not only that, the number of routers will be definitely big because it's a big organization. More routers, more networks. So the quantity of routing information exchange between the peers is too much. So if we don't do summarization, it cannot be effectively, the efficiency of the network will not be that effective. Meaning, if you keep sending too much of advertisement every now and then, consuming more bandwidth, you may say, no, I don't have any problem with the bandwidth, we got 10 gig links. But what about the process utilization? Every now and then, if you send too many updates, all those updates need to be processed by every router. This is more excessive. So we have to do proper summarization in order to reduce the excessive bandwidth processor utilization by this EIGRP. Next thing is, if there is any change in a topology, the number of routers in our organization that gets impacted should be less as much as possible. One small change, if every router needs to converge like Corona, one virus started in one place, everyone in the world should put masks. See, the impact was too much. But if someone gets a common cold or cough, not everyone, maybe the next person or the family. The neighbor, they don't catch cold because you got cold. It's not that bad impact. The number of people get impacted is not that big if it is a normal flu. But this flu like Corona, the entire world get disturbed. Same way. If your EIGRP updates that you send impacts small group or one router, it's okay. Not the entire topology all the time. That needs to be in control. The number of routers that must be involved when topology change occurs should be less much possible. Otherwise, whenever a small update comes, all the router reprocess it. Sometimes they jump between the routes. So shuffling the path will impact in ARP issues and many more. So we need to do something so that number of routers that will be involved when a topology change occur will be less. Next, the depth of the topology. What is the meaning of depth of the topology? The number of hops the information needs to travel to reach every router. So how many routers are involved? Again, it's same like second point in a more detailed way. The depth of the topology is equal to the number of routers. But sometimes number of routers may not be in a linear fashion. It may be like a circle. One router connected to 5 routers. That is also number of routers, but there may be sometime like this. One router connected to 6, 7 in a serial manner. This is one way, number of routers. There is another way. There's simply number of routers. This is depth of the topology. If a change happens here, if these routers are getting impacted, this needs to send this one, this needs to send this one, this one. But here it is not like that. At the same time, boom, boom, boom. When an update comes from here, it goes to everyone. So the number of routers and the depth of the topology, we need to do something to avoid these impacts. And then the number of alternate path. See, if you don't have an alternate path, there will be some issues like stuck inactive scenarios. If you have more number of alternate paths, how many number you are going to use? Those things can be configured. Now, these are the things that we need to focus more when you are in enterprises for improving the scalability. These are the things that will impact. If you don't have alternate path, definitely there is going to be impact in the scalability. If there is too many routers involved in every single change, then definitely there will be bad impact. The scalability will be very poor. The number of routers that must be involved when the topology change occurs matters. Okay. So let's see what is said in this page, in this book, this chapter. I'm sorry. EIGRP query process. EIGRP, whenever there is no alternate path, it will send a query because it don't have alternate path. When is the query sent? You had a path, but now the path is no more. So the router wants to know another path for the destination. So it will start querying every neighbor. Neighbor, I lost the route. I lost the route which was comfortable, passive. Now I'm putting it in an active state, meaning now I'm in an active state. I'm looking for an alternate path. That's what active means. We are going to learn struck inactive. This is what that active means. Meaning I'm looking for the alternate path. I had one nice path, but now it's no more available. That path is no more available. I'm looking for an alternate path now. I lost the active. I lost the passive state path. Meaning passive means good here. Passive means everything comfortable. I got a path and the packets are moving. That's what passive means. But active means I lost the route. That's why it is in active state now. Meaning it is still searching for an alternate path. So it searches the alternate path by sending queries. Queries are sent when the route is lost and no feasible successor is available. The lost route is now in active state. The queries are sent to all the neighboring routers on the interface except the interface to the successor, meaning this router has a successor route. This is the direction where successor, meaning to reach a destination, this is the best path. So the destination is somewhere here. Now there are some other neighbors which may be connected to this cloud, may not be also like this. May be connected, may not be also. Listen, try to understand the scenario. This is router 1 wants to reach this network 11111. This is the destination. The routes are advertised, and this is the successor route to reach 11111. The other routes are not alternate path. You know why? Feasibility condition not met. This route, they didn't meet the feasibility condition. So this is the only successor route. I don't have a feasible successor. There is no feasible successor. And when the successor says, when this router says, don't come to me anymore, I am no more a successor. Now router 1 is going to query to router 3, router 4, router 5. It's going to query router 3, 4 and 5. See, if the neighbor do not have the lost route information, the queries are sent. If the router has an alternate, we are in third point, sorry, read third point. Queries are sent to all neighboring routers, means 3, 4 and 5, on all interfaces except the interface of the successor. So will it be sending to R2? No. It won't be sending to router 2. Router 2 already said, I am no more a successor, please don't come to me. So R1 will start querying only 3, 4 and 5. Okay, queries are now there with router 3, 4 and 5. Router 3, 4 and 5 will send an acknowledgement. Router 3, 4 and 5 will send an acknowledgement. Acknowledgement is not a route. Acknowledgement is like, okay, I got your query. Now, what if the neighbor do not have the route? See, if the neighbor do not have the lost route information, the queries are sent to their neighbor. Meaning, if router 5 don't have the answer for the query, it will send to router 6 here. Router 4 don't have an answer, router 4 will send the query to router 7 here. Router 7 also don't have an answer, it will send the query to 8 here. See how many routers are getting impacted. And router 3 don't have an answer, router 3 sends to some routers. At last, this router 3 somehow says, okay, yeah, I have an answer. It comes to router 1 and say, router 1, this is the administrative this is the advertised distance via me. So R3 says, you can come through me, this is the advertised distance. But R4 and 5, will they respond? No, they are no way connected to 11111. See the fourth point, if the neighbor do not have the lost route information, queries are sent to their neighbors. Means 4 is sending to 7, 7 is sending to 8, their neighbor. If a router has an alternate route, meaning router 3 has got an alternate route, it answers the query. So only router 3 is answering the query. No other neighbors can answer. Because 4 cannot answer. Because 7 cannot answer. 7 also cannot answer because 8 cannot answer. 8 cannot answer because it do not know anyway. It's not connected anyway to 11111. Likewise 6 also cannot answer. And so 5 cannot answer. Now R1 got an answer only from router 3. Because, router 3 has answered. Meaning, let's say there is one router here, R100. R100 has an answer. 1111 is connected there. So there is no more query. Query will not go to R101. That is the meaning of this one. Last statement. If the router has an alternate route, it answers the query This stops the query from spreading in that branch. So in this branch, after 100, it won't go to 101 because 100 knows the answer. 100 will respond to 99, 99 will respond to 98, and then router 3 will give to router 1. So we have understood these points. Let's move on to the next. We understood here, when will the query process happen? Begin. When will the query begin? We have seen when will this query begin. Query begins when the route is lost, when the successor is lost, and when there is no feasible successor. The query process will start. Querying will be done to all the neighbor except the successor, except the neighbor which was a successor. Now query, if it is sent, if there is no answer, it will be sending to the next neighbor. Keep going till a neighbor provides a response, and then the spreading of query will stop. Like this is not a good idea. Look at this. This is not a good, okay, you need to have some clarity here. Don't compare this one with this picture. This page is not completely explaining what is happening here. So we have just learned a part of the problem. Problem is, when the successor goes down, feasible successor will query all the neighbor. If one neighbor knows the answer, it responds, and the query spreading will be stopped only in that branch of network. But on the other branches, still the queries will be forwarded to the next neighbor. See the impact of the topology change. See the number of routers that are involved. See the depth of the topology. This is what the points that we are trying to understand from this scenario here. So we have to somehow avoid this big problem. You see, the successor has gone down. B was using this path as a successor. It's no more. Now B started querying about this network to its neighbors A. A started querying to its neighbor C. But C already got another query from B. And C is querying A. And A is querying C. See, pathetic thing. B is querying, A is querying B because C was querying A. So it's going back. And then A queries D. D queries A. B queries A and A queries D again. See?
Hello, sir.
A big mess.
Actually, if successor failed, okay, there is no success. What about second alternate one? Either he will have alternate one, second alternate one. What's the problem? If there is no successor and there is no alternate path, then only this querying all that will happen. Am I correct?
Very correct. See, we had a successor, but now it is lost. When it is lost, immediately it will make a feasible successor to be a successor. But the problem here is there is no feasible successor. Only in such scenario, these queries will start. See, EIGRP is not having the real topology table. That's the problem. Whereas OSPF don't have this issue because OSPF has got the complete topology table. The real topology table is with OSPF. So OSPF will not query like this and wait. We are going to learn about OSPF next, no? So I'm just trying to give you a clear picture why OSPF is better than EIGRP. You should know that. EIGRP is not really fast in convergence compared to OSPF. OSPF is the fast converging protocol. But if you compare to RIP, EIGRP is fast, no doubt in it. But this is not the fastest convergent protocol. This is comparatively faster. Compared to RIP, it is faster. The OSPF is the fastest converging protocol because it maintains the topology table, complete link state database. So one successor goes down, and one successor goes down immediately. Immediately when one successor goes down, it goes to the database and checks whether there is an alternate path. If it is there, it will use. If it is not there, it won't query, which means it is not really available in the topology. Because the complete database is with OSPF. But in EIGRP, there is no complete database. There is no complete topology. EIGRP advertises the routing table. Tell me, what will be there in the routing table? The best routes. If only best route is given to me from my neighbor, am I having complete topology information? No. My neighbor has not sent me everything. He sent me only the best route. He sent me only the best route. Yeah. So, updates and queries in the hub and spoke topology is what we are focusing. If you have hub and spoke topology like this, see the mess that happens here. They keep on sending the query to everyone, but no one is going to respond because no one is connected to this network in any manner. You send it to C will send it to the following neighbors. That following neighbor will send it to their neighbor. No one knows. They will be keep on flooding this query. And C is also coming back and giving to A is giving back to C, B already sent to D, that is also coming to A. You know, this is not going to make your protocol better. This is going to make it worst. EIGRP will start consuming more processor and the scalability will be a question mark. So what is the solution for this? Stub is the solution. To avoid this problem, you need to configure stub. What is stub then? How can stub solve this problem? How can stub solve this problem? Stub can solve this problem by simply sending a special peer information. See this word, third paragraph. Special peer information packet to all the neighbor router to report its status as a stub router. See, the special packet was not sent earlier, so you had this mess. Meaning A, C, D and E. A, C, D and E, if it would have sent earlier to B saying B, wait a minute, I'm not a superhero here. Don't ask me whatever you don't know, whatever the problem you face. Don't bring it to me. I know only these things. You question me these things, I will answer about these things. What does that mean? It means that don't simply query me for everything. C, D, E and A, C, D, E and A so where are we? This is what. So if C would have told B earlier, you cannot ask query about these networks, meaning you should not ask everything. You can ask only these things that I know. The problem would have not occurred. Do you understand what I'm saying? Please respond. Do you understand what I'm saying? Do you understand the solution for this problem?
Yes, sir.
This is what stub means. Stub means the routers are going and telling the hub routers, especially this is on hub and spoke topology. The stub, EIGRP stub, is more important for hub and spoke topology. So what we do is in hub and spoke only we'll have multiple alternate paths. No. Will you have alternate paths if you have something like this? No. Only when you have like this. This is what hub and now this is what spokes. There only there is a possibility for alternate paths. So that's why we are learning hub and spoke. So C and D and E should be configured to report to A and B that they are only capable of doing these work. That will solve the problem. B won't query unnecessarily. See, you have a team member and you are the manager. If your team members are straightforward, you are giving an assignment. If team member says, "Sir, I don't know what you are asking me to do," then problem solved. You would have given that to someone else. You will not be waiting for him to finish which is not going to finish because he don't know. So that unnecessary wait time can be avoided, no? In networking, it's very sensitive. Fast convergence is what very important. So, configuring EIGRP stub reduces the wait time. The stub routers, the routers that we configure as a stub, they send a special peer information to all the neighboring routers about the status that it's a stub router, about saying I am a router who is capable of supporting only these networks to you. There will be a flag on. I'll capture and I'll show you. There will be a flag on as a stub, which means whatever I am giving now, only about that you need to query me. For the other networks, I am a stub. Meaning, don't ask me and waste your time. That's the meaning. The EIGRP stub routing feature improves the network stability, reducing the resource utilization and simplifies the remote router configuration. So, the problem solved. Network is stable now, not simply querying and waiting, unnecessarily wasting the resource by sending query, utilizing bandwidth and process, and simplifies the remote router configuration, meaning you no need to do something special to improve the stability. It's very simple. Configure stub on the spoke. Spoke will simply go and send a special message that solves the unnecessary query and getting stuck in that active state. Second point, the stub router is commonly used in the hub and spoke topology. The fourth point, the neighbor that receives the packet informing that of the stub status does not query the stub router as for any route. So hub router will not unnecessarily keep querying after knowing that the neighbor cannot support. Only if the hub router knows that this neighbor can support us, it will query. Otherwise it won't query. So EIGRP stub improves the network stability. You see the first point? The number of routers that must be involved when topology change occurs is now reduced. You are not going to query everyone. You are going to query only those routers which may have an answer. Mostly it will have an answer because Stub is sending a special message saying these are the networks I'm very good with. You can query about these things. So before configuring Stub, it was a big mess, you see. It was a big mess here. But after configuring Stub, C, D, E has reported. C, D and E has reported to both A and B saying, I am a Stub router. See, Stub flag is set now. Earlier, it was sending only route advertisements. It was sending route advertisement, but no Stub flag set, meaning if no Stub flag is set, B may now query for those routes which C, D and E have not advertised. Now when the Stub flag is set, what does that mean? It means that B cannot query those networks which is not advertised by the spokes. B can query only about those networks that are advertised by the spokes. Spokes advertised, but it is not in the feasibility condition. So B did not use it, but advertisement was sent. Though B was not using earlier. Why? The feasibility condition was not set, but advertised by C, D and E. But now B will query. B will query because it said I'm a Stub router, I'm responsible for these networks. So B queries only to those neighbor who advertised earlier about that network, but earlier it was not in use because there was another successor and this didn't satisfy feasibility condition. I think I made it clear when the Stub and where the Stub and how the Stub solves the problem of distributing the queries to many neighbors. Configuring Stub gives more cleverness to the hub router whom to query and whom not to query. There are 5 different types of Stub we see. There are 5 different types of Stub. First one is simply like what you see in this example, EIGRP Stub. When you configure EIGRP Stub, there are 2 types of Stub getting enabled. One, Stub connected, SubSummary. So now how many type of Stubs we have learned? 2 types. No, 3 types. Stub connected is one type. SubSummary is one type. Stub itself is another type. When you say Stub, it enables both, no? So that is a 3rd type. Stub connected, SubSummary, Stub, or Stub connected, SubSummary. 3 types we have seen. The other 2 types are Stub static, Stub receive only. These are the 5 different types of Stub. See? Receive only, Stub connected, Stub static, SubSummary, And when you simply say stub, it enables both connected and summary. So in total, how many we have? 5. If you simply configure EIGRP stub, the default is connected and summary. So depending on our topology and the network configured on spokes router, we configure any one of these on each spokes. So if you read the first one, receive only, what does this mean? If you configure EIGRP stub receive only on the spokes router, the spokes router is telling the hub router, do not query anything to me. Prevents the stub from sending any type of route, meaning that spokes router will not send any type of route, meaning that spokes router says to hub router, I will not give you anything, so don't ask me anything. Simple. If you give, I'll take. But I will not give you anything. No routes I have to give you. So do not send me any query. That's what called as receive only. EIGRP stub, receive only. Prevents the stub from sending any type of route. Next, EIGRP stub connected. What does this mean? EIGRP stub connected, meaning this says I know only my connected network. I got connected network. See, this in the bracket, don't take it serious. It is only for some routers, XR routers. For XR routers, you need to redistribute the connected also. Then only it will advertise. In some devices, not in all devices. So, you see, when we say connected, permits the stub to send connected routes only. Meaning, if you configure C router, if you configure on C router saying EIGRP stub connected, what does this mean? It means that it's physically connected network, no? The network on this interface, this interface, this interface. C will say only these 3 network I know. If you have any query on this, you are most welcome. Please ask me. Only these 3 networks are connected to me. But other networks that I might have learned from someone, I'm not responsible for that. I'm advertising you those routes, but don't query about those routes to me. If you want, I'll advertise. Again, if you want only, it won't advertise by default. It advertises only the connected. When you say EIGRP stub connected, it advertises only the connected network and take responsibility for the connected network alone. See, assume that there is no other router here. No other router. Now, if you say EIGRP stub connected, that is very good. Because there is no other network. So, B will not query about this network to C. It won't query about the network. B will query only those 3 networks that C knows. That solves the problem. So C will say, you see, these are the networks that I have. I'm giving you. I don't have anything else. Don't ask me anything else. Only these 3. You can ask me. I'll answer. Yep. So that's what. Yes. Question.
Yes, sir, I have a question. So, like we have configured C, D, and EIGRP stub So do we have to also configure for B and A, wherein C is supposed
No.
C also there is
No. This is only on the spokes router. Only on the spokes router we have to configure this.
So sir, if C does not find a feasible successor or something, then it will query the EOA. So suppose C wants to reach the other network.
See, these are all spokes routers. This is not hub router.
Okay.
So only the hub router has got alternate paths via D, E. Likewise, A has got alternate path via C, D, and E. A is also another hub. So you query only those spokes routers. Spokes, there won't be a need for spokes to query hub because the spokes router learns everything through the hub. Hub is the only, only this will be active or this will be active. Either this will be active or this will be active. Let's say B is active now. So A is not even considered by C. According to C, C is here, C is connected to B, and B is connected to D, and B is connected to E. According to C, there is no alternate path to query. There is no other neighbor to query, right? Other than B.
Yes, sir.
Anything that comes is coming from B only. So, if the primary path goes down, means that is the path via B. If the primary path goes down, it has to query the other neighbors. Why it will query again the same B where the primary path gone down? You understand?
Yeah. In this scenario, C will query.
It won't query anyone. C will never query query to B. See, if a network from E, let's say 1.1.1.1 is gone, C was reaching this 1.1.1.1 via B now earlier. Now B said, I don't have 1.1.1.1 anymore. I don't have. So now C will query its neighbor, but there is no its neighbor. There is no neighbor for C anywhere, and there is no one else is neighbor for C.
Okay. There is single neighbor too.
So for all the tail end trees, there is no more connectivity. Only having connectivity.
Yeah.
So for those tail end routers, we need to configure them.
Yes. See, if you have many other routers behind C, there are options available. See, we are now talking only about the connected. For the connected, that answer that I gave now will suit. If you have many routers behind C, then you might have done what? A summarization for all the network. Yes or no? You might have done what? Summarization for all the network. And this time you will say SubSummary. So what does that mean? You are telling B that that I am responsible for anything that begins with 10. If you have any query related to 10 network, you may ask me. Means it's a summary. It's not connected. Though 10.1 is connected, is 10.2 connected to C? No, it's not connected. Is 10.3 connected to C directly? No, not directly connected. So if you say stub connected, then that will be wrong. You need to say stub summary in this type. When you say stub summary, C is taking responsibility for all the subnets of 10. So depending on your scenario, you need to choose one of this. So when I say stub connected, the router takes responsibility only for the physically directly connected networks. When I say stub summary, it takes responsible for the routes that is in the routing table in a summarized manner. In a summarized manner. Yeah.
Okay, got it.
Next, stub static. When I configure stub static, only the static routes which are already written by you. You know what is static route? You have written some static route. Now you may think like, what is the connection between static route and a routing protocol? EIGRP. There is a connection. You see, you got a static route and you have redistributed into EIGRP. Those routes are going to be advertised as what? External route. What is the administrative distance? 170. EIGRP administrative distance 170 is for external route, meaning routes coming from some other source. What is the administrative distance of EIGRP? 90. But for the redistributed route 170. So those redistributed route only you want to take responsible, then you do this command. EIGRP stub static. If you put EIGRP stub static, if there will be a static route redistributed in D says I am responsible only for these static routes. Means these external routes. Don't ask me anything other than this. That's the meaning of static. EIGRP stub static. A summary I have told you. Only the summary route it takes. If there is a summary route in the routing table, only for that it takes responsibility. Connected means it's both connected and summary. Yeah. So what we are going to do is in our next class we'll revise one more time with this nice examples here, and then we will do one lab exam. Sorry, one lab. When we do